Yes, good morning, everyone. What we were discussing in the last class, I think VLAN is completed. VLAN completed. Inter VLAN done. On DTP we have done as well. So I think in inter VLAN I have given you one task to configure using multiple interface. Have you tried that? Yes. You got the result? No. So I have given you that you have to take one router, then one switch, and two PCs. See, in the router on a stick method, we used to use only one interface towards the router. But here we will be using here two interfaces. So now what will happen? That interface G0/0. Yeah, so this is going to be G0/0. So this side, this interface will be acting as a default gateway for this PC, and this interface will be acting as a default gateway for this PC, right? Whereas in the case of router on a stick method, we were having only single interface, and we used to create sub interface, and that were acting as a default gateway for respective networks. So we'll assign one IP here. 10.1.1.10/24. IP for the PC will be 10.1.1/24. On this, we'll assign IP as, let's say, 20.1.1.2, or let's say, yes, 20.1.1. Or we can go with 10. Only 10.2.2.10/24. And this was going to be 10.2.2.1/24. Okay, different network. So this one is a part of one VLAN, let's say coming under VLAN 10. And this one is a part of VLAN number 20. Let's leave it, VLAN number 10. And this is going to be VLAN 20. Now, for that, we used to inform the switch about the available VLAN. So come to the switch first. CLI, give enable config space T. Now, first we will tell that what are the VLANs we have on the switch. That is VLAN 10 and VLAN 20. I'm not assigning any name to that. Okay. Then we have to inform based on the interfaces as well. So now, see, first you will tell that on which interface we have this VLAN 10, interface F0/1, right? So interface 1 F01 switch port mode is access and switch port access VLAN 10, right? But don't you think that this interface F03 will carry the information coming from VLAN 10 only? Huh? Yes, no. You tell me that this particular interface that I have taken, extra interface on the router G0/0, and it has been connected with the interface F03 of the switch. It means we have a single dedicated line to carry the information coming from VLAN number 10. So this is also what? Access only. Here trunking is not required. When you require trunking, trunking is required only when you have a single link and that is going to carry multiple VLAN information. Here it is going to carry single link, single VLAN information. That's why here also what is required? Mode access only. Right. So one more interface we have on the switch that is called as an interface F03. And this is also switch port mode access and switch port access VLAN number 10. VLAN 10. Correct? Then again on the interface F02, switch port, mode, access, and switch port, access VLAN 20. This is regarding the interface number F0/2. Same as you have to inform regarding F04 also. Correct? So interface F04, switch port, mode, access, switch port, access, VLAN 20. Got it? Now come to this router. Enable config space T. Interface G0/0. IP address is 10.1.1.10, 255, 255, 255.0. No shut and give exit. Interface G0/1. IP address 10.2.2.10, 255, 255, 255.0 and give no shut and give exit. Configure the IP, that's all. Then you come to this PC's desktop IP configuration, assign the IP 10.1.1.1, 255.255.0. Default gateway will be what? 10.1.1.10. Got? Same come to this PC. Desktop IP configurations 10.2.2.1, 255, 255.0. No, IP for the PC I'm telling. 10.2.2.10 will be a default gateway, right? Now come to this PC and try to ping. Pinging. Got so devices in different VLAN can also ping using this method. So in this method, what is not required? Trunking is not required. If tagging trunking is not there, then what is the role of tagging only? The reason because we have a dedicated connectivity for each separate VLAN. That's why. And this is only the limitation of this particular method, because when you will be having multiple more numbers of VLAN, so each VLAN requires a dedicated connectivity from the router side. And router does not have that many ports. That's why we use router on a stick method. Is it clear? So we have discussed regarding this SVI router on a stick method, and even we have discussed using multiple interfaces. Any questions, any doubt? Huh? Where? Which one? InterVLAN. See, like there can be one question that though we have this particular thing, we can go with that one more method. No, rather than having VLANs, if we are going to segment for segmentation purpose, why we are using VLAN only? If we have a switch, with that switch, if I want to divide the broadcast domain, I can use different network addresses also on a same switch, on a same. We can have multiple PCs. So one PCs will be of one IP, other PC will be of other IP. In that case, also we can break the broadcast domain. But what is a why do we prefer this VLAN? The reason because with the same IP only, with the same IP only, not actually with the same IP, with the same network only, we can break the broadcast domain. This is the advantages of the VLAN. But what about the other functions? Like we can say it requires configurations, right? It requires to have the communication. Like if you have to enable the communications between different LAN, then you have to use all other methods to have the communications. Okay. And see, whatever we have done till now, so it is based on a negotiation, like not about the VLANs, but what we did whenever we are doing trunking. So what happens in the trunking? It negotiates with other port, no? For example, let's say I have taken a switch. This is switch 1 and this is a switch 2. And between them we have a connectivity. So this is interface is F01. And this side we have as an interface is F02. Now, if you have done trunking on this switch 1, then what will happen? Automatically, the interface of switch 2 will become what? Trunk. How it happens? If we will give a command, interface F01, I'm giving a command switch port mode as trunk. Then no need to give this command on switch 2, right? On the interface F02, right? With this, what will happen? With this command, F01 will act as trunk and automatically it will negotiate with other port, with other directly connected port. That is F02 of switch 2 and will convert the port as trunk. Okay. This negotiation takes place based on protocol that is called as DTP. Right? What it is called as DTP. And what is DTP? Dynamic trunk.
Dynamic.
DTP is dynamic trunking protocol. Now, it is a Cisco feature, means it is applicable with the Cisco devices. In this, what happens? It has two modes. One is auto mode and one is desirable. By default, the switch port will be in auto mode, right? Auto mode will not negotiate to form trunk. It will accept the request from whom? From desirable. It means who is going to negotiate there? Desirable mode only. So who will negotiate? Desirable. So what is desirable mode? This mode will negotiate to form trunk. It means that if we have two port, on a switch 1 we have F01, on a switch 2 we have interface F02. So among these two interfaces, one should be in the desirable mode. If both the ports are in the auto mode, then what will happen? It is not going to form the trunk. At least we need to convert one of the port into the different modes. So in the DTP, what happens? No, apart from this auto mode and desirable mode, this is a default. We can directly convert the port into desirable mode with the command switch port mode dynamic desirable. And this will ask to form trunk with other ports, or directly we can form trunk using with the command switch port mode trunk. Both these commands are useful to form the trunk. As DTP is a Cisco proprietary, so we will be using this command switch port mode dynamic desirable with the Cisco devices, right? So let's take switch, two switch we have taken. Host name is S1. Now give exit and check the interface status of the F01. How will you check? So interface F01 switch port. So interface F01 switch port. Now it shows that what is the admin mode and what is the operational mode. Okay. Admin mode means what? How the device has been or how the interface is like configured. And operational mode means how it is operating, how it is configured and how it is operating. So by default, what is the admin mode? Dynamic auto. And when it is dynamic auto, it is not going to form the trunk, right? In this set also we can see here on the switch to CLI, enable config space T and change the host name to S2. Give exit and verify. So interface F01 and switch port. What it is? Access, and it is in auto mode. So if it is in the auto, what will happen? It is in the access. It means they have not formed the trunk. To form trunk, what is required? Desirable. See, if I will give a command here, come to config space T and give interface F01 switch port mode dynamic desirable. This is the command. Switch port mode dynamic desirable. Give exit. Now again you verify. Do show interface F01 switch port. What is the admin mode? Desirable. We have only converted this. And what is the operational mode? Done. And this side. So interface F01 switch port. Auto only. But what it is? Yeah. Trunk. So it means one side auto, one side desirable. What it will form? Trunk. So it means we can write it here that if we have one side auto and other side is also auto, then what it is going to form? Access. If I having one side as auto and other side as desirable, then what it will form? Trunk. Right? Now you verify. Again, let me do it one more thing. That let's say this side what we have auto no. I will change it to the try desirable only. So interface F01 switch port mode dynamic desirable. Give exit. And now you verify do show interface F01 switch port desirable and what it is. It means can I conclude that desirable and desirable will also form what? Trunk only. If I have both side as desirable, then it is also going to form what? Trunk. Auto access, auto desirable, trunk, and desirable desirable, trunk. Clear? See. So it says here that DTP is a Cisco proprietary that is used to negotiate automatically to establish a trunk links between the interconnected switches. So it simplifies the trunk configurations by dynamically determining if a trunk link should be formed and which VLAN should be carried over it. Then DTP are established by the switch port by sending what? Dynamic trunking protocol packets to negotiate whether the other end can be the trunk port or not. If both ports can successfully negotiate based on the agreement, the port will become the trunk. So what is the advantage? See, if you have taken here three switches, now if I need to configure trunk on all the side, on all the connected port, then if I am forming trunk here, it negotiate with this port to form trunk. If I am forming trunk on this interface, it negotiate with this to form trunk. You can even the more like easy method is you come to this switch to configure this interface and this interface as trunk. It will negotiate with this port to form trunk and it will negotiate with this port to form the trunk. Okay. So here what is the advantage? Manual tasks will be reduced. No need to configure trunking on all the ports. Okay. Now, but as it is going to have certain advantage, it also has certain limitations. What if you have taken these two switches, right? It can form trunk. Now this switch that you have, this is one attacker device. Okay. Now if it is an attacker device, so if it has formed trunk on this interface, don't you think that this port will automatically negotiate with this port and it will form trunk? And if it is forming the trunk, then what will happen? All the messages, all the information will be transmitted. So it will be compromised. That's why Cisco itself says disable the trunk, DTP. Cisco itself says that do not use dynamic trunking protocol. If devices is having the inbuilt feature of DTP, you can disable it. How will you disable it? With the command no negotiate. If you're giving this command interface number no negotiate, it will not negotiate with other port to form the trunk. In this case, for example, let's say this is my switch. I know this is my LAN environment switch. So I don't want that any other port should form trunk with me. So what I will be doing here, I will form on this interface as no negotiate. In this case, what will happen? If this port is trunk, it still it then also this port will be access only. It is not going to form trunk. until and unless manually we have configured it. Now, if you want to form this trunk here also, then you have to come to this interface to form the trunk. You cannot form it from other switches. Got the point? Correct? So this is the command to disable the DTP, dynamic trunking protocol. But if we like talk apart from this, so but it is a good method only that is going to establish a trunk between the interconnected switches. Benefit is what? It reduces the manual tasks. Fine. So how many modes we have in DTP? Auto and desirable. See. So if one side we have is a auto, other side auto, what it is going to form? Access. One side auto, one side desirable. Then I can also give a command, no, interface number and switch port mode trunk. Instead of giving dynamic desirable, I can also form trunk also, right? So if one side auto and one side trunk, what it will form? Trunk. If one side auto, one side access, then access. Okay, remember this. Auto and one side access. Access. You can verify all these things while giving the commands. Now, different, one more method. If one side desirable, one side auto, trunk. Desirable, already we have seen trunk. Desirable trunk, trunk only. And desirable access, access. So again, you have to write this point. Desirable access, access. What about this one? Trunk and auto? Trunk auto? Trunk. Trunk. Trunk desirable? Trunk, and trunk access. It is not going to form. You try with this command. You form one side trunk and other side as access. See what happens. They both will mismatch. And if it is mismatched, then how it can be possible? Right? No? Yeah. Same as access auto, access. Access desirable, access trunk. Again, it is not going to form. What about access and access? Access.
Access and dynamic desirable is
Which one? Which one?
access dynamic desirable.
This one. Access. Why it is? So let's say that
Vishal, so DTP is not being used currently?
I'm like, if we cannot say that it is not being used, already we have some switches where the DTP is the inbuilt features. But it is told
But
that, okay, you can, like, if you're aware that, okay, there can be certain other devices also, there can be a chance where other devices can be connected to my switches and can form the trunk. So in that case, you need to disable this DTP case.
so
But when
if
you
I
are,
remember yeah,
mm, mhm,
in L3 switch, you said like, the encapsulation dot 1Q also we did it in L3 switch. So in
right.
that case, in L3, it is a safe. It'll be keeping safe from the attacker to be attacked.
See, for example, if you are going to prefer this also, you can prefer in the LAN environment. If I
Okay.
have my own environment, multiple devices, I know that there is no any possibility of any other devices getting connected with my switch, then I can prefer this DTP. And they also it is useful also because no need to configure DTP on multiple ports. So this is the advantage. There I can prefer. But I don't know if any other port, if any other switch can get connected and can form the trunk, and I don't want that other port or other should negotiate to form trunk. In that case only I have to disable it. And for disabling it only we give the command no negotiate. So it depends upon the scenario where you are going to use this particular thing.
Okay. Thank you.
But when you will use this, when you will give this command no negotiate command, no, then always you have to form the trunk on the multiple ports.
Okay.
We have to
Got
give
it.
the
Thank you.
commands. Now, if I'm giving here interface F01 as switch port, mode, dynamic, desirable, correct? Give exit. Now come to this switch. Interface F01, switch port, mode, access. Access it is. Huh? So it is in trunking only, and this side we have the access. What it found? Static access only. Right? That's why desirable and auto is going to be static access. Right? So it is telling you here that if we have one side as a desirable and one side as a static access, and it is going to form the access. And same, if we have both sides as access, then that is default only. Exit is going to form the access. So access and access, here see access. Okay. So you can verify all these methods. You can verify using the commands. You take just two switches, change one of the interfaces according to this, and then you verify what you are getting. And you have to change other side like this. Okay. So this is regarding the DTP. Clear till here? Now, what happens that let's say in my LAN environment, I have one switch. Okay. On this switch, I have connected certain PCs. And for that, I have VLANs. Okay. So on this switch, I have created VLAN number 10, VLAN 20, VLAN 30, VLAN 40, and VLAN 50. Fine. Now, as you know that in my LAN environment, I will be having more numbers of end devices. So for that, what is required? Again, multiple different switches. So I have certain more switches. Switch 1, that is switch 1. This is switch 2. This is switch 3. Okay. Total 4 switches I have. This is switch 1, switch 2, switch 3, and switch 4. Now what happened that as I was having all these 5 VLANs configured on the switch 1. So I wanted to have all these 5 VLANs on switch 2 also, switch 3 also, and switch 4 also. Consider that with switch 1 I have 50 PCs. So PC number 1 to 10 is a part of 10. PC number 11 to 20 is a part of VLAN 20. 30 to 40 like that to 40, and till 50 we have VLAN number 50. Okay, like that. So same on the switch 2 also, I was having certain numbers of PCs on a switch 3 also and on switch 4 also. And for that all PCs, I wanted to have VLAN 10, 20, 30, 40, 50 like that. Now, if I want all these 5 VLANs on switch 2 also, switch 3 also, and switch 4 also, so what is one task? I need to go individually on all the switches. I need to configure all these 5 VLANs on a switch 2 also, on switch 3 also, and one switch 4 also. Don't you think it is going to be very like lengthy process? Okay, for these three switches, it can work also. What if I am having one numbers of switches? What if I am having one numbers of VLAN? Then what it requires always manual configuration, right? So do we have any other option where if I am creating as multiple VLANs on a switch one, this multiple VLAN should be present on switch two also, three also, and four also automatically. If among the, let's say all among these five VLANs, I am going to delete this VLAN number 20, for example. So from switch one, it will be deleted. And I want that if I am deleting it from the switch one, it should also be deleted from the switch two also, three also, and four also, and it should be automatically. How this should happen? Based on protocol that is called as a VTP. Okay, and this is called as a VLAN trunking protocol. What is VTP? VLAN trunking protocol. See, the name suggests that this is a VLAN trunking protocol, but actually it is not a trunking protocol. It is like a management protocol. The reason? Because it manages the VLAN configurations. What it does? It manages the VLAN configurations on the switches, right? So what happens now? That see here. Now, if I am having a switch one, so switch one will be having VLAN number 10, 20, 30, 40, and 50. It means on all these switches, I can create the VLAN, right? But on the switch 2, switch 3, and switch 4, I don't want to create. What I want, it should take automatically from where? Switch 1. So the switch where I can configure the VLAN will be in the server mode. And by default, I can create all the VLANs on all the switches. So by default, the switches will be in which mode? Server mode. All the switches will be in the server mode where I can create the VLANs. It means my switch 2, switch 3, and switch 4 will also be in the server mode. But I don't want to create VLAN, no. I want it to take it automatically from the server mode. So I have to change the mode of these switches. And for this, in which mode I will change? Client. Which mode? Client. What the point? What is happening here? So switch 1 will be in the server mode where I can create the VLANs, whereas switch 2, 3, and 4 will be in the client mode where I don't want to create the VLAN. It means in this client mode switches, I can't create. It will take it automatically from the server mode. That's why we have different modes in the VTP. What are the modes we have in the VTP? One is server. What happens in the server mode? We can create, delete, and modify the VLAN configuration. This is regarding what? Server mode. Then we have is a client mode. In this, what will happen? We cannot create, delete, and modify the VLAN configuration. In this, what will happen? The switches in this mode will collect the VLAN information from the switch in server. So if I am deleting the VLAN on server mode switch, then what will happen? The client mode switch will automatically delete it. Is it clear? Then we have one more mode. That is called as a transparent. In this mode, we can create the VLAN. We can create, delete, and modify the VLAN information. We can delete also, we can create also, and we can modify also all the VLAN information. But all these changes will be locally present on the switch, on the transparent mode switch only. So for example, let's say I have taken one more switch, switch number 5. And on the switch number 5, I have created multiple VLAN information, 60, 70, 80, 90. So that 60, 70, 80, 90 will be present only that particular switch number 5. So switches in the transparent mode is not going to collect any VLAN information from the server. Neither it is not going to share any VLAN information to the client. Whatever it is present, it will be present on the transparent mode only. So we can say it is going to act as a independently. This is, we can say, independent switch. Okay. I'm not telling that it will not receive the VLAN information. You have to remember one statement. It will receive the VLAN information from the switch in server mode, but it will not maintain its own database. Right? It will receive, but it is not going to maintain its own database. Means if 10, 20, 30, 40 is present on a server, so transparent mode switches will receive that part, but it is not going to store that information. Right? So we can say here that transparent mode switches will be acting as a independent switch, neither taking anything from the server, neither giving anything to the client. But it can act as an intermediate device where it can collect from the server and send it to the client. But it will not maintain its own information, database information. Till here it is clear?
So can there be multiple channels?
We can have.
So if you're offering different different switches,
Hmm.
how will clients represent on which switch you have to?
This depends upon the configuration revision number. And this is not a part to discuss here. Configuration revision number? Yes.
So little I'm still confused about the transparent mode. I understand what it works, and I don't understand the purpose of this because I understand it's kind of a backup, right?
We can have, let's say, it might be possible, no, there can be other switches also. And on that other switches, I don't want to configure anything. Right. Now, for example, let's say I have taken here 3 switches, for example. Now, this is my switch number 1. This is switch number 2. And this is switch 3. Now, let's say on the switch number 1, we have configured certain VLAN 10, 20, 30, and 40. Now, this is my server mode switch. This is my client mode switch. Now, I want that this switch 3 should have this 10, 20, 30, and 40 VLANs. But I don't want that switch 2 should have this. I don't want that this switch 2 should have 10, 20, 30, and 40. For that, what is required? For that, I need to convert this switch to act as what? Transparent. When it will act as a transparent, in this case, what will happen? That it will take the VLAN information 10, 20, 30, 40, and it will just forward it to the client. It will not maintain its own database. Right? Now you will tell me that, okay, fine. Then why don't you just convert it to the server mode only? If I will convert it to the server mode, don't you think that there will be 2 server mode switches? Huh? And if I have configured more numbers of particular VLAN information on a switch 2, then what will happen? See what happens in the VTP if you have 2 switches as a server. Now, understand the basic, what is the meaning of configuration revision number? What happens? That if I am adding a VLAN, no, so your configuration revision number will be 1. If I am adding one more VLAN, it will be 2. Now I have added 2. I want to delete 1. It will become 3. It means if I'm adding, if I am deleting, what happens? Always your configuration revision number changes. What happens? Configuration revision number changes. In this case, what happens though? The switch with the higher configuration revision number, from that only the client switches will take the VLAN information. For example, if I'm having 2 switches as a server mode, switch 1 and switch 2. Switch 1 is having 10 CR, a configuration revision number, and switch 2 is having 12 CR, that is configuration revision number. So this client mode switches will always take the VLAN information from the switch who is having the highest configuration revision number. Okay, and this is one of the demerits of the VTP.
But you said the transparent, the mode, whatever we are doing the changes, it will be not updated to the server, not to the
Right,
client.
right.
Then how the client is knowing the CR numbers?
Where? But that's why I told you, no, that transparent mode will be collecting the information from the switch 1, will be forwarding it to the client. I'm not telling you that this is not acting or this is not doing anything. It will do the activities, but it will not maintain anything. Let's say, for example, there is one middleman, right? Like postman. What he does, he receives your letter and delivers it to the destination. Is it he's going to keep a copy for that? No.
No.
Same it is acting like transparent. It's like an independent switches. But if I wanted to create certain VLAN information, I can create over the switches. This is one of the advantage. If I am creating one of the VLAN over this switches, then it is not going to share. Means whatever I will be creating on the transparent mode switches, it will not share that thing. It will share only the things that has been given by the server.
Okay.
Got the point?
Yeah.
That's why we can call that it is acting as a independently.
But usually in the transparent mode, people used to do create, delete, or edit anything.
Right. We can delete and edit anything. And do you know one more thing, that if on a switch server switches, I'm having 10, 20, 30, and 40. No, I know that this switch to transparent mode switches will not have this 10, 20, 30, and 40. But I can create 10, 20, 30, 40 over this transparent mode switches also. Same VLAN information. I can create.
Okay.
Even though if you create, a client will get information from server.
Huh. Client will not collect any information from the transparent, right? So to form this VTP, there are certain criterias. Criteria to form VTP. If you want to write here, note it down. VTP version should match. If configured, if password is configured, then password should match on all the switches to form the or to participate in the VTP. Modes should be defined, right? Domain name should be assigned. Why domain name is required? To identify that all this particular device belongs to a same domain. It means a same local area network. So what functions we are doing here? We are managing the VLAN information on the switches. Now, as if I am telling here that VTP version should match, it means VTP will be having different versions. So VTP has 3 versions: version 1, version 2, and version 3. Even VTP is also a Cisco feature. VTP is a Cisco proprietary protocol that simplifies the VLAN management and propagation across a network of interconnected switches. Now it allows the VLAN configuration changes to be automatically propagated to all the switches in the VTP domain. So VTP simplifies the management of VLANs, minimizing the need for the manual configuration on each switches. That's why I told you that this is a management protocol, but the name suggests as a trunking protocol. Now it has different modes. See what it says: server mode. So the default mode for the switch is what? Server. This is a default mode. In this mode, you can create, delete, modify the VLANs, and those changes are propagated to all other switches in the VTP domain. It means here you have to define the VTP domain name, and whatever the switches coming under that VTP domain name will be receiving that particular changes, right? Client mode. Switches in this mode can receive update about the VLAN changes from the VTP server, but cannot make their own changes. Mean they are completely dependent upon what? Server modes. They depend on the server to handle the VLAN related configurations. Whereas what happens is transparent. Switches operating in this mode do not participate in the VTP updates. It does not participate in the VTP updates. They maintain their own VLAN information independently. And this mode is useful if you want to configure VLAN locally on a switch without affecting the VTP domain. Okay. Now I want to have a same switch in a same VTP domain. And I don't want it to create any other VLAN information, or I don't want it to share its own VLAN information. For that, I have to convert this switch into the transparent port switches. Got the point?
And Vishal, sorry, another one question. So
Hmm.
whatever the updates will be done in server mode, but still the transparent mode will be getting updates from that, right?
Right.
Okay. Okay.
It will get the update, but it will not maintain it.
Okay, I got it.
Just I wanted to show you the differences between the versions. So see VTP version 1. It supports VLAN from 1 to 1001. Remember this. What it supports? Till 1001. It means VLAN number 1 will support only normal VLAN. It does not support or does not recognize extended VLAN. It lacked the support of what? Token rings. We can say VTP version was little older versions. Then we had VTP version 2. See, same functions as VTP version 1, but with added enhancement. What it does, it supports token ring, includes consistency checks for certain operations like renaming the VLANs. If you will rename the VLANs, that will be also modified. Now, in this, what we have, transparent mode switches can forward the VTP advertisement in version 2. It means in the VTP version 1, the transparent mode switches was completely independent. It was not participating only. But in this version 2, what it does, it participates at least to advertise the villain information. Right? In which version? Version 2. These are the advancement that we got in the version 2 compared to version 1. Whereas in the case of version 3, it supports extended VLAN range, a significant improvement. It supports extended VLAN ranges, right? Again, it supports for database other than just VLAN database. For example, it can manage MST, multiple spanning tree. You will discuss this in the switching, CCNP switching, MST, right? In this, now I told you that in the VTP version 2, we can have multiple servers, but it depends. Even if you have more than one server, from where it is going to collect the information depends upon the CR value. It means I can have only one server in that case. But in this, I can have primary and the secondary VTP servers. One more advantage. You can define this is my primary, this is my secondary. Where we have this version 3. Even we can support what? Private VLAN information. Clear? So now I will show you the configuration using VTP version 2. Version 3, like in the VLAN also, we have one concept called as a private VLAN. Okay. So private VLAN and VTP version 3 will discuss. This is a part of CCNP level. Okay. And this private VLAN is more towards security feature. Okay. Where we will be having different methods. So let's take switches. And one more information. See, if you have to form this VTP, then like what we are doing every time, that we are sharing the VLAN information, right? Multiple VLAN information using what? Single connectivity. So it means here trunking should be done. If trunking will not be there, then how it is going to share the information? Correct? No? So this is the switch one that I will put into the server mode. This switch will be in the transparent, not transport. and this switch will be in the client mode. On server switches, I will create certain VLANs 10, 20, 30, 40, and 50. Fine. On transparent switches, I will create VLAN 10, VLAN 100, and VLAN 200. And client mode switches should take all this information from the server mode. Okay. Now to form, we will be using a VTP domain. So first come to this switch. Enable config space T. Host name will give it as a server. Okay. Now to form this VTP, first we need to define the VTP version. So Cisco Packet Tracer supports only two versions, 1 and 2. So it says that 1 and 2 set the admin domain VTP version number. So we will be using here VTP version 2. Okay. Now VTP mode. See, when you will give the question mark after writing the VTP mode, it shows here we have the client mode, server mode, transparent mode. Now, when will you write the server? What it says, device mode already in the VTP server, because this is the default mode. That's why. So first we need to define the version, then we are defining here the mode. Then after that, VTP domain. Let's say cisco.com. Okay. Then what it says, that changing the VTP domain name from null to cisco.com. Okay. First it was null, means nothing was there. Then we had now cisco.com. Then what is there? VTP password. What is the password? Let's say I'm writing here 1234. What it says, setting a device within database from to the password is 1234. And it should match. If you will not give the same password, then it will not collect the VLAN information. Done? Clear? Come to the transparent mode switches. Enable config space T. What is the host name? Transparent. Okay, then first what we need to define here? VTP. Which version we are using? Then VTP. Domain is what? Sorry, mode is what? Transparent. Then VTP domain. We have changed it to cisco.com. So cisco.com. Then VTP password. What is the password we have given? 1234. And come to the last switch. See why I have taken transparent mode switch in the middle, so that I wanted to show you that it will collect the VLAN information and it will forward it to the client, but it will not maintain its own database. That's why. Enable config space T. Host name is client. Then VTP version 2. VTP mode is client. VTP domain cisco.com, and VTP version. Sorry, version no. Password no. 1234. Yes. Done? Okay. Now you check on this switch. So VTP status. Show VTP status. What it says? VTP operating mode is what? Server. Now what is the CR value? 0. Why? Because we have not configured any VLAN, that's why. Correct? Same as you can check it on this switches also. Show VTP status. What is the operating mode? Transparent. And here, show VTP status client. Now, we'll come to this first switch. Configure the VLAN information here. VLAN 10, VLAN 20, VLAN 30, VLAN 40, and VLAN 50. Fix it. Show, do show VLAN brief. See, all this VLAN has been configured here: 10, 20, 30, 40, and 50. Right? And again, you check do show VTP status. 5. How many VLAN I have created here? 5. And it is showing also a CR value as 5 only. Now, what will happen? This client will take this, show VLAN brief, no information. So VTP status, still it is 0. Why? Trunking is required. So where I will do the trunking? Come on the transparent switches only I will do, so that it can negotiate using what? DTP. On both this interface, I will be doing F01 also, F02 also. So come and give this command. Interface range F0122. Switch port mode as trunk. Give exit. Right? Now you check on the client switch. Show VTP status. What is the CR value? And show VLAN brief. 10, 20, 30, 40, 50 is present. So server is having, same client is also having. Now check on the transparent switch. Do show VTP status. Transparent, and do show VLAN brief. Do we have any VLAN information? Only one by default, one VLAN number 1. Correct, no? So can I create here? Yes. VLAN 10, 100 and 200. VLAN 200, VLAN 100. Give exit, show VLAN brief. Now see, 10, 100 and 200. It means I was having 10 on the server mode switches also, and same I'm having on the transparent mode switches also. Same VLAN I can have, but it is not going to collect from the server. It will collect, but it will not maintain it database. Understood this? Got? Check, show VTP status. So what is the CR value in the transparent mode switches? 0, even if we are going to change here. Then also it shows as a 0 only. Now, if I am going to delete any VLAN information from the server mode switch, then what will happen? It will be deleted from the client also. So now you give no VLAN 10, no VLAN 20, and no VLAN 30. Give exit. Show VTP status 8. Why? I told you, any modification, whether you add whether you remove, it will count as one, not only adding. And show VLAN brief. Only 40 and 50 is present. Now check it on the client mode switches. Show VTP status, see here also, 8. And show VLAN brief, 40 and 50. Got the point? Write down the commands. First, what we write? VTP version. So we will define here which version we have to use. 1, 2, or 3. Then what we have? VTP mode. So what are the modes we have? Server, transparent, or we have as a client. So any one mode we can use. Then VTP domain we have to write here. And then VTP password. Not mandatory, but we can give. Even VTP is also a Cisco feature. Clear till here? Understood this?
In transparent mode, we have to do trunking also, right?
Trunking is required. Trunking is required here. So this we have completed DTP and VTP. We can. Okay, see, we have here switch 1, switch 2, and switch 3. Okay. Now, you know that what is the feature or how the switches performs. So it sends as a broadcast message, correct? So what happens that if switch 1 is sending something to the switch 2, if some information is coming from switch 1 to switch 2, then what happens? Even switch 2 will send this information first to the switch 3 in a form of what? Broadcasting. And if it happens, and don't you think that even this switch through will send this information further to the switch 1 again as a broadcasting? Switch 1 delivered to the switch 2, it receives, it broadcasts, even switch 3 also broadcasts. So all these three switches, when switch 1 is sending something, switch 2 receives, it forwards it to 3, and same information again will reach to the switch 1. Don't you think that same information is being circulated here? Same information is being circulated. So when it happens, what it does, it causes a virtual loop, formation of virtual loop. Information will be keep on circulating, right? This need to be avoided. Now, how it should be avoided? See, as you know that, okay, if switch 1 is sending something to the switch 2, then it will send it to the switch 3. What if switch 3 receives that, but it does not forward it to the switch 1? If this happens, then formation of loop can be avoided here, right? So in that case, what can happen? That let's consider that this is one of the this is there will be one of the port. Let's say we have made this interface F0/0 manually as shut. We went to switch 3 and we have given a command interface F0/0 and shut. In this case, what will happen? Interface F0/0 will be down. If it is down, it cannot forward any traffic. So in this case, if switch 1 is sending to the switch 2 will forward it to switch 3, but switch 3 will not forward it to the switch 1. Why? This interface is down. So with the help of this, what is the main advantage? Formation of loop will be avoided here. But what happens now? Let's consider that, okay, fine, we did the same thing. Later on, what happened? That because of certain reason, my interface F03 automatically stopped working. I have not done anything. It automatically stopped working because of certain reasons. Now, if it happens, in this case, what will happen? My interface F0/0 is also not working. Interface F0/3 is also not working. Then what will happen? It will not be possible to reach the switch 3. Means communication will not happen till switch 3. It means it will be isolated, right? In this case, what is required? That I need to come to interface F0/0 and manually I need to make a command no shut, because manually I have make it shut. So manually again I have to make it no shut. In this case, what will happen? It will come up, and if it is coming up, then I can reach the switch 3. This is one of the method, and it requires always manual intervention to identify one of the port, make it shut, make it no shut according to the requirement, and we don't depend upon the manual things. That's why we have a concept that is called as a STP, spanning tree protocol. So in the complete STP, you will be using only single line, single command. And with that only, everything will work. And that too also, that is not used for configuration purpose. That is used for just checking purpose. Okay. So what happens in the STP? It is a layer 2 protocol defined under IEEE 802.1d, where it identify one of the port and it make as a blocked port. What it does, it make that particular port as what? Block port. But what is the advantage of that? If any other port is not working, it will automatically come up. Which port? Block port. Otherwise, if all the ports are working normally, then that particular alternate block port will be in the blocked status only. And if it is in the blocked status, then what will happen? Formation of loop will be avoided. Clear till here? So is it only possible with these three switches? Like the scenario will happen only with these three switches? No, it can happen with the two switches also. How? Now, instead of having these three switches, if I'm having two switches, then for example, what happened that I was having a switch one and switch two. Now there was a one connectivity between these switches on the interface F0/0 and here also F0/0. Now what happened? No, then I was worried that if this port is not working, then communication will not happen between my switch one and switch two. That's why for a backup purpose, I have taken one more connectivity between them. Two connectivity, F01 and F0. As soon as I will take this, then what will happen? Formation of loop. Because you know that if I am having multiple ports, then what will happen? It will keep on sending via the two ports. You will send, it will send it again. Again, it will send it again. So this can happen between the two switches also, not always with the three switches only. So when it can happen with the two switches, when you have more than one connectivity between the two switches. Clear till here? That's why what we use? Spanning tree protocol. Now what happens? Now, as I told you that, okay, I will identify this port and I will make it as a shut, manual intervention. Now, if I am having a STP, this is the inbuilt feature of the switches. This will be running on the switches. Now, it is going to identify one port and it will make it as a alternate block port. Let's say it has identified F0/3 and this is not working now, right? So there can be a question, no, how it is going to identify that this port only will work, not work, or this one will not work, or this one will not work. On what cases, on what is the criteria to have? So we'll discuss that point first. First, let me show you how it is happening. If I will take two switch, it can work with any of the switches, either it is layer 3 or layer 2. Now between them, I will take multiple connectivity. Come to options, preferences. Are you seeing this? Remove this. Not visible. It will take time. We will forward the timing from here and see here. These are in the green color. Green color. This is orange. Orange means here it is alternate block port. If it is down, it means it is disabled. It is not disabled. It is alternate block port. It means it can come up when it require. How it is doing automatically? I am not done anything. Just it is identifying because it can cause a formation of loop. That's why it is putting one of the port into the alternate block. Same as if I will take three switches like that. I'm taking here layer 3 switches. It also what will happen? We can forward the timing. See here, this is in green color, green, green. This is also green, this is also green, and this is in the orange. There can be a question that why only this port in the orange? Why this port is in the alternate block state? Why not this one? Why not this one? Why not this one? So there can be condition based on that only. The switches is identifying that which port will be the alternate block port, right? So we need to discuss that particular conditions. Till here, any questions? Any doubt? Any questions? Because this is very important to understand STP process. This condition only, how it is going to elect that. Because in STP, we don't have any commands. We have concept, and this concept is very much important. Right, so it depends upon one election process. That we'll discuss now. STP is what? Spanning tree protocol. It is defined under IEEE 802.1d standard. It means this is not a Cisco feature. It can be applicable with other devices as well. Right? So it uses process. It uses election process to identify which port will be alternate block. Which port will be the alternate block port. So for that, it uses election process. So first is what? First step is election of root bridge. Election of root bridge. So we can write here that the switch exchange BPDU messages every 2 seconds. What it sends? BPDU messages every 2 seconds. What is BPDU? Bridge protocol data unit. BPDU contains bridge ID. What is bridge ID? MAC address
Priority number.
plus priority. So the switches exchange BPDU messages every 2 seconds. BPDU is bridge protocol data units. It contains the bridge ID information. Bridge ID, the MAC address of the switch plus the priority number. Okay. Next, the switch with highest bridge ID will be root bridge. The switch with the highest bridge ID will be the root bridge, and the port connected with root bridge switch will not be alternate block. Got the point? What it says? The switch with the, sorry, it is not highest, it is lowest.
Port can be blocking state.
Read the statement. The switch with the lowest bridge ID will be the root bridge, and the port connected with the root bridge will be not alternate block port. It means it will be the forwarding ports. Which switch? The lowest bridge ID switch. Okay. So see, let's consider that switch 1 is having a MAC address of A. We can consider like it has a MAC address A, and the priority number is 32768. This is the default priority number. So you can write it here one more point. Default priority number is 32768. Can we change this? Yes, we can change this. This is the default pattern. Now, as the default one, so let's say that we will be having a default pattern number on the switch 1 as 32768. On a switch 2, we have is like a B and 32768. Here we have C 32768. Now, like when we were discussing about the MAC address, there I told you that value of A is 10, B is 11, C is 12. So if A is 10, so among all these three switches, who is going to have the least bridge ID? See, if they have
Switch
same
1.
priority number, so we need to compare with using the MAC address. So switch 1 is having the least MAC address A, and it is going to be 10. That's why this is having the least bridge ID. So now, according to the statement, it says that the switch with the least bridge ID will be having the port, and that is not going to be the alternate block port. It means that this port is what? Forwarding port, and it is also the forwarding. Right? So among this 1, 2, 3, 4, 5, 6, how many ports we have? 1, 2, 3, 4, 5, 6. Among this 6 port, 2 port has been eliminated. These 2 will be not in the blocked status. How many left? 4. So again, one step will take place to identify which port will be blocked. Second step. Election of root. Election of root port. The port which provides the best path to reach root bridge from non-root bridge is called as root port, and root port will also not be alternate block port. It means that if any port is the root port, that port will also not the block port. Read the statement what it says.
Node bridge provides the best to reach node bridge from a non-root bridge is called root bridge.
What? Now you tell me among these three switches, which switch is the root bridge switch? Huh?
Both are same.
Switch one is the root bridge. No. What is the criteria to have root bridge? Whoever is having a least bridge ID, right? So switch one is what? Root bridge. Switch two and switch three, non-root bridge, right? No. This is my root bridge. This is root bridge. And these are
Non-root bridge.
non-root bridges. Now again you read the statement and you tell me which one is the root port. See here, read this. It means here I have two switch as a non-root bridge, switch 2 and switch 3. So first we will talk about the switch 2. Now from the switch 2, if you want to reach root bridge, that is your switch 1. So you have two options to reach there. One is via F01 and one is F02. You tell me which one is the having the least cost. F01. Let's consider that you are using here one cable, fast Ethernet, and here the cost is 19. In STP, the cost is going to be 19 if you use fast Ethernet. Right. So if this is the cost, then here I will, if I need to reach switch 1, if I am going via F02, the cost will be 19 plus 19, 30. And if I am going via F01, the cost is going to be 19. So which one is less via F01? So which port is providing you the best path to reach root bridge? F01. So what is the root F01? Root port. Here F01 is root port. Correct? F01 is what?
Root port.
Root port. Same as if we talk about this one from switch 3, which one is your root port? Same here also. So this is going to be the root port. If it is root port, then it is in the up state. It is also not going to be blocked. Right? How many we have port? 6. Among these 6, 4 if we have identified that this port will not be blocked. Then last is left. Okay. Now the last one says that the switches that is left, among them we have switch 2 and switch 3. Among them, who is going to have the least bridge ID?
02.
02. This means switch 2. So whoever is having the least bridge ID, that switch will be having the forwarding port. So if switch 2 and switch 3, we have B is 11, C is 12. So obviously switch 2 is having the least bridge ID. So among that also, one will be the forwarding port. Which one is left? The last one. This one is the block. So last selection, it will happen. First is third step. Election of designated port. The ports that are left and the switch connected with that port has least bridge ID will be designated forwarding port. And the last one is election of alternate block port. And the switch with higher bridge ID will have alternate block. Got the point? How it is happening? So this is all the process STP will perform. Everything is automatic. You don't have to do anything. Switches will do everything. But how it is doing, that is very important to understand. Clear? Election process. So first it will look for the root bridge. The switches that is having the lowest bridge ID will be the root bridge. Port connected with that root bridge will not be blocked. Always it is up. Then root port. From non-root bridge, the port that provides the best path to reach the root bridge will be also not blocked. Then the switches that are left, among them, whoever is going to have the lowest bridge ID will have the alternate forwarding port. And the last one that is having the higher bridge ID will be the forwarding block port. Clear, clear? In any case, if switches is having the same bridge ID, in any case, if switches has the same bridge ID, in that case, election will happen based on the port numbers. Right. For example, if among F02 and F03, somehow what happened between this switch 2 and switch 3, bridge ID was not able, like we were, switches were not able to compare using the bridge ID. So they compared using the port numbers. And that is called as a port ID. So in that case, what will happen? By default, port number will be there. That is called as a 128. That is a default port number. And the port ID. So among this F02 and F03, is whoever is going to have the higher port ID, that will be the alternate blocked port. Right? So if port ID is what? Port number plus priority number. This is 128. But first comparison will take place based on the bridge ID only. If it is not able to compare using that, then only it will use the port ID. And if priority number is same 128, then it will compare using the port numbers. Like if we have F02 and F03, so obviously F03 is the higher one, so higher one will have the alternate block port. Clear? So in the STP, we have certain more topics that has to be discussed, like states. What are the states we have? Because as I told you, what happened in the Cisco packet tracer, when we were seeing that which port will be the alternate block port, so we used to forward the timing from here, right? Because it takes time to identify that which port will be the alternate block port. In that case, it will have certain timings. So that's why we need to understand how much time it takes to come from the forwarding state from the block state. Okay, that timing we'll discuss. Port states will discuss, port types. Then after that, we have BPDU guard, BPDU filter in the STP and port fast. Then we'll start with the RSTP. Tomorrow we'll complete STP. And see one more thing, that if the port numbers are visible now, see. Now at present, this port is what? Alternate block port, no? Now let's say this F02, we are making it down. It means it stopped working because of certain reasons. Then what will happen? That port has to come up automatically. That's why we call it as an alternate block port. Make interface F0/2 as SUT. Then it's not working now. Now still it is a alternate block port. It will take time to come up. Forward the timing from here and see it came up automatically. Correct? If again that port is available, interface F02, make it no shut and give exit. And again you verify, see, it will come to alternate block port automatically. Right? So we'll use one command to check this. I am on the switch first, top one. Give command show spanning tree. Show spanning tree and see this is a spanning tree. What it says, STP is running here. What is the priority number? 32769. What I have told you? 8. Why it is 9? Because it is adding one VLAN information that is called as a VLAN number 1. That's why it is 32769. Adding VLAN ID. Okay. Now, what it says, what is the hello timer? 2 seconds. It means how frequently it sends this BPTU messages. And what is the maximum age timer? 20 seconds. As I told you that in STP, if you will use fast Ethernet cables, the cost will be 90. That's why here the cost is 90. Okay. Now, what is the interface number F02? Alternate blocked port. And what is F01? Root forwarding port. Where is F01? This one. If this is your F01 and it is telling you that this is my root port, it means that this switch is your root bridge. Right? Verify. Give exit. Show spanning tree. What it says. This bridge is the root. It means this is the root bridge switch. And the root bridge switch will be having the forwarding port. So here also forwarding, here also forwarding. Correct? No? This is designated forwarding port. Next, check here. So spanning tree. F01 root forwarding port. F02 designated forwarding port. Right? Point P2P means
Here.
point-to-point connectivity. The current switch connectivity is point-to-point. This is the priority number 128 by default, the port numbers. Clear till here? Any questions till here? Tomorrow we'll start with the STP states and we'll discuss all the timings there. So just let me show you one more thing. Yes, so why do we need this STP? So STP is a network protocol that ensures a loop-free topology in Ethernet networks by dynamically disabling and enabling the specific switch ports. It prevents broadcast storms and network loops that can cause network outages and performance issues. Spine tree protocols is a network protocol designed to prevent loops. It is a layer 2 protocol. Which layer protocol? Layer 2. And it operates based on the STP operations, so by electing a collection of root bridge switches that become the focal point for the network topologies. So each switches in the network calculates the shortest path to reach the root bridge based on the lowest path cost, typically based on the link speed it calculates. And it happens with the help of switch port that is categorized to the states. Total 4 states we have, and that 4 states only we'll discuss later on tomorrow. So port states, then port fast, then BPTU guard, then BPTU filter. Today we have complete DTP, VTP, and STP process. That's it. We'll stop the recording.